In this video, we discuss about full subtractor. So, full subtractor logic diagram, it seems like this. So, we already discussed about full adder. So, what is the difference is like that only the inverted output of A will be given to the two AND gates here. So, in previous video, we discussed about full adder. So, if you don't watch it, then go through that, then it is easy to understand what is the difference between the full adder and full subtractor. In full adder, we simply use ABC as the inputs for the AND gate, but here we can observe a NOT gate here. So NOT gate, what is the here the ABC will go into the XOR gate and the output will be the difference of the full subtractor, and there is a borrow. So while you are performing the subtraction operation, then we get what difference between the two bits are. Sometimes you get may get borrow also. So now what you have to do means, so for generating borrow, to calculate the formula for borrow, so we can do the AND operation between the inverted of A and the B and inverted of A and C and the B and C. So by using this we can collect all the AND gates outputs to the OR gate. So we get the borrow output as like this. So the difference formula is A XOR B XOR C, and the borrow output is A bar B plus A bar C plus BC. This is our borrow formula. Now we can remember these two formulas. By using these two formulas, we are going to calculate the means performing the code in Verlog. So before going to that, we have to know truth table. So how many variables are there? There are the three variables. What are there? ABC. So we have to get difference and the borrow. So three variables means we get 8 combinations. 2 power 3 is nothing but 8 combinations. So 0 0 1 up to 1 1 1 like that. So difference. So what you have to do for calculating difference? We have to use the formula 0 XOR 0 XOR 0. I simply substitute these ABC values in this equation, and then we can simply done the performance operation. So 0 XOR 0 is nothing but 0. So again 0 XOR 0 is nothing but 0. So difference is 0. So for borrow we can substitute here 0 bar, and the B is 1 plus A bar means 0 bar, and the C value is 1. Sorry, C value is 0 and B value is also 0. Plus B value is 0, C value is 0. So for in 0 bar is nothing but 1 of 0 plus 1 of 0 plus 0 end operated with 0. So again 1 end operated with 0 we get 0, 1 end operated we get 0, and then 0. So whole the borrow will be 0. Like that we can calculate all these different combinations and find out the truth table first. Then after you get simulation, you can cross check whether you are doing the performance what you have to done is correct or wrong, like that. So it is our design code for full subtractor. So in Verilog code we already discussed about that. The Verilog code is between the module and end module. So we have to give module name here. So after module we have to give module name. It is about full subtractor. That's why I mentioned the module name as full underscore subtractor. It's up to your choice. You can give any name, but it should be started with small letters like that. So no need to mention any numbers or special characters like that. So what are the inputs port here in the full subtractor? A, B, C are the input ports. So simply for representing the input port, we can simply write the input keyword and the A, B, C. And for the output, we get difference and borrow. So for that, we simply write output for representing the output port, difference comma carry. You can write borrow also, no problem at all. It is up to you. Whatever the variable you can give, you can assign that value to that variable. So assign, why you write assign means for assigning RHS value to the LHS side, you simply use the assign keyword in data flow modeling. So assign, so difference. So what value you have to assign to the difference? So difference formula is nothing but here you can observe A XOR B XOR C. So simply assign the A XOR B XOR C. Then the output of the A XOR B XOR C value will assign it to the difference by using this assign keyword. And what is the formula for carry? A bar B plus A bar C plus BC. So in between A and B there is an AND operation. In between A bar and C there is an AND operation. Here BC also there is an AND operation. By AND operation will be represented ampersand in Verilog. In Verilog language we can represent AND gate symbol with ampersand, and whereas OR gate symbol with single line like that. So there is a bar, we can represent that bar with this character like that. So by using this formula you can represent in the Verilog code like this. So you can stop with end module. It is about design code. If you have any doubts till now, you can comment it. So let's move on to the Testbench code. So Testbench code, whatever the code in the Verilog, it must be start with module and end with end module. So first we have to write module, and after that we have to give module name here So it will be up to our choice. It is a test bench code, that's why I written TB. So TB represent the test bench, so that's why I represent like this. So you can give any name. So for inputs ABC are mentioned in the reg data type, whereas the outputs are mentioned in the Y data type. Why I use reg means, so because whatever the variables we are using in the initial block, it must should be reg data type. So that's why I particularly mentioned the reg data type. So every video we discuss that the inputs may be reg data type or net data type, but output must should be net data type only. So why you mention every time reg means, because these variables, whatever the variables of input will be used in these initial blocks, that's why we simply use reg data type. So what are the inputs we simply mention in reg data type, what are the outputs we simply mention in the Y data type. So now what you have to do, this design code is instantiated with this test bench code. To creating connection between these two codes, we have to simply write design code module name, whatever the design code module name here we write. So simply write the design code module name here, and you can write some instance name. So no need to write any particular name, you can use any name, but mostly we use DUT and DUT in our Verlog codes, because it is a design under test, which is something professionality and certain meaning to that code like that. So it is our nothing but it is our instance name. We can use any name. I simply write my name, because when you are always write DUT, then your mind fixed that only DUT you have to write, otherwise you get error like that. So that's clarification I want to give, that's why I mentioned my name. So if you use any name, but for according to our understanding or according to Verlog, we mostly use DUT and DUT. You can use any name. For that specification I mentioned here. So this is about the port connection. Port connections are two types. One is name and then is order. So how we connect the ports is already discussed in previous video. If you don't watch, just look into that video. Then you can understand. Here I connect by name or name. In some codes I connect with order. So you can choose anything, but prefer mostly by name, because by this name we don't get any confusion or like that. So like that. So after instantiate, then then we go to giving inputs to the variables, input variables. So for that initial, and there is a multiple statements in initial block, that's why I use begin here. So initial begin. So what are the variables, input variables A, B, C are our input variables. So 3 variables means we get 8 combinations. So you can give any different combinations, and for every combination you give some delay. So /5 is nothing but our delay. So giving some delay between the combinations, where and then use $finish for stop the simulation. For stop the simulation, we simply use the $finish keyword like that. So end with, for this begin we can end with end keyword. So for these 4 lines, every video I say that for these 4 lines we have here the code is executed in EDA playground. So that's why for to get waveform in some languages, means some compilers or some RTL tools, no need to mention these 4 lines, because they directly get waveform, like inbuilt there is a getting waveform and output like that. But when you want to generate a waveform in EDA playground while you are running, so you have to write these 4 lines and then end with end module. So after run the full subtractor code, then you get the output like this. For whatever the given combinations, I give combinations like this, so that's why I get an output like this. So here I observe, I take this part value. So you can simply double click in this scale, then you get the values on your left side. So A is equal to 1, B is equal to 0 and C is equal to 0. So you can simply substitute the formula A XOR B XOR C. So 1 XOR 0 XOR 0. So 1 XOR 0 is nothing but 1, and 1 XOR 0, again this value you can write here. So 1 XOR 0 is nothing but 1. So our difference value is 1. So here the difference value is 1. So it is correct. So carry formula A bar B plus A bar C plus BC. So A value is 1 means 0 of 0 plus 0 of 0 plus 0 of 0. So simply you get 0. So here you can observe carry will be 0. So it is about our full subtractor code and the waveform and the output and the test bench code. If you have any doubts, you can comment it, and thanks for watching. Until then, bye.